Hi students, this is a vodcast over the atomic structure of an atom. This is the first of two vodcasts that you will be watching. I encourage you as you're watching this to take as many notes as you need to in order to familiarize yourself, first of all, with the scientists' work concerning our knowledge of the atom, but also the structure of the atom itself. So please don't try to write down everything on this page. Take notes as it helps you. If you're confused about note-taking or you don't know where to start, please let me know and I can give you some tips. So we take for granted that we know about atoms now. Let's go back in time and try to figure out how the atom structure was determined. The earliest picture of the atom, what we really knew about an atom or what we envisioned it as is this sphere right here, a hard lump of something. And a scientist, John Dalton, came up with an atomic theory. He said all matter is made of atoms. All atoms are indivisible. That means there's nothing smaller than an atom. They can't be broken up into any tinier parts. Atoms of a given element are identical, and atoms combine in whole number ratios to make compounds. So this was a pretty revolutionary idea at the time, and Dalton did a pretty good job. What you'll find as we're moving throughout this unit is that he wasn't 100% correct. He was wrong on item number 2 and item number 3. So I challenge you as you watch this podcast to try to figure out where Dalton was wrong. We can kind of start to answer that question if we look at the work of J.J. Thomson. He was the first person to discover electrons. He set up an experiment. You'll be watching that in your video reflection. This is in 1897. And he found out that when he took a type of ray, which we call a cathode ray, and subjected it to an electromagnetic field, there was some little particle in there that was attracted or repelled by that electromagnetic field. And it was a particle that scientists had never really seen before, and they came to call this particle an electron. And we now know them as negatively charged subatomic particles. Subatomic means they're part of an atom, smaller than the atom. So that already takes us back up here to Dalton's theory number 2. He said atoms are indivisible, nothing smaller than an atom. J.J. Thomson took that idea and disproved it. What else was going on in 1897? Amelia Earhart was born, one of the most famous female pilots ever. Dracula is published, Boston Subway opens, and we first started using the word computer. So a little history for you. Okay, not only was Thomson able to tell us what an electron was, he was also able to figure out that they barely had any mass. They had a negative charge, but there wasn't much mass. And so he did some work with what we call the charge to mass ratio. So scientists started thinking, okay, if we have this thing called electrons and they're negatively charged, there must be some other force or particle holding those electrons in place. And we didn't know what that was exactly, but that was a big idea that scientists started talking about. So Thomson's big idea was he proposed this thing called the plum pudding model. He said, all right, all these negative little electrons, they're kind of like plums inside a pudding. They're negatively charged, but what's holding them in place is this positive sphere that they're kind of stuck in. He said it reminded him of pudding. So we called this the plum pudding model. This was one of our first pictures of what we thought maybe the atom looked like. So we went from thinking that an atom was just a big lump right here to thinking that an atom was kind of more of a hazy type of positively charged material with negative little particles stuck in it. So after we had this idea of these negative little electrons, then a scientist, Rutherford, came along, and in 1919 at Cambridge University, he performed a now famous gold foil experiment, which you will also be watching. And when he set up this gold foil experiment, he essentially discovered the nucleus of an atom. And the nucleus of the atom, he said, must contain some kind of particle that's oppositely charged from the electrons, and now we call those protons. Some other big things going on in 1919. You can see them there. The Versailles Peace Conference begins. Those Boston White Sox threw the World Series, and alcohol became illegal in the United States. Rutherford's big idea during all this world turmoil is that an atom is made of a small, dense, proton-containing center, which we now call a nucleus, and it's positively charged, and so around it are those negatively charged electrons, and he was thinking of them kind of like little negatively charged planets orbiting this positively charged center. He wasn't correct about that, but it was a good place to start. So then scientists started asking, how do these positively charged particles stay together? If they are there in the nucleus, wouldn't they repel each other? Wouldn't they push away? And so then scientists developed this idea of a strong nuclear force. That's the force that holds the nucleus together. It's incredibly strong, but only over short distances. So we went from not knowing at all what an atom looked like to knowing that it had electrons to now knowing that it has a nucleus in the center that has a lot of energy inside of it. Then another scientist came along, James Chadwick. He was a prisoner of war in Germany, but before and after the war, he was able to work on the atomic theory, and he really studied the nucleus. He wanted to know more about why the nucleus was so heavy, so he used a particle detector to prove that the nucleus contained both positive and neutral particles, and those neutral particles came to be called neutrons. So now we know about electrons, we know about protons, and we know about neutrons. They are all part of an atom. An atom is not indivisible, it's made of smaller things. This information down here is a summary from a lab that we did not perform, so don't worry about that. But now hopefully you have a little bit better understanding of how we got from where we were to where we are today with what we understand about the atom. And we're not done yet. Scientists worked on determining the mass of atoms. So essentially what they did, they started comparing hydrogen, helium, and all of these elements, and from that they were able to deduce how many protons, neutrons, electrons atoms have. They began arranging this info on the periodic table. So if you look down here, you'll see a box on the periodic table. We call this an element block, and in it are some numbers. That top number for every element is called the atomic number. That refers to the number of protons. It also refers to the number of electrons in a neutral atom. Then we have the element symbol right here, and then we have the atomic mass down here. And what you need to know right now is that the atomic mass of is the mass of one atom, and it's measured in something called AMUs, atomic mass units. So the protons and the neutrons are very, very massive. And so this number down here reflects the mass of that nucleus. The electrons hardly have any mass at all, so they are not reflected there in that average atomic mass. So you're looking at the periodic table, just want to get you familiar with what some of these letters and numbers mean. Okay, so if hydrogen has one proton, we need to understand why are the atomic masses on the periodic table a decimal. So right here, why is this atomic mass 1.008? Why isn't it just a whole number? You can't have part of a proton or part of a neutron, so how do we get that number down there? And we're going to get into the math of that eventually, but what scientists did discover is that there are several different forms of hydrogen. There are several different forms of helium and of lithium. So they discovered that two atoms of the same element didn't necessarily have the same mass, and that goes against Dalton's atomic theory. He said every atom of an element is identical. He said all hydrogen atoms are exactly the same. All lithium atoms are exactly the same. We now know about isotopes. Those are two atoms that have the same number of protons, but a different number of neutrons. So for example, this element right here is lithium. It has 1, 2, 3 protons, and it has 3 neutrons. This element here is also lithium. It has 3 protons and 4 neutrons. The atomic number is what gives an atom its identity. You'll notice I took the electrons out of here just to not confuse the issue. So this is an isotope of lithium, and this is also an isotope of lithium. So we can write the symbol for isotopes in the following way. We put the element symbol here. We put the mass number on top. That's the sum of the protons and the neutrons. We put the atomic number on the bottom. So this isotope symbol right here is the isotope symbol for this lithium atom up here. So if we were going to write the isotope symbol for this element, what would we write? It's still lithium. It still has an atomic number of 3, but the mass number up here is 7. That's how we would write that isotope symbol. So down here, here's some more common isotope symbols. Here are 2 isotopes of carbon. They each have 6 protons. but this one has 6 neutrons, this one has 8 neutrons. Over here we have uranium. Same number of protons, different number of neutrons. You add the protons and the neutrons together to get that number up top. Sometimes you'll see isotopes written this way: lithium-7, carbon-12, carbon-14. This is the isotope name followed by the mass number. So this particular isotope of carbon up here we would call carbon-12. This one here we would call carbon-14. This isotope of uranium here we call uranium-225. So that's how we say those isotope names. So after watching this vodcast, hopefully you have a better idea of some of the work done by scientists. You should understand that protons, neutrons, and electrons are the 3 subatomic particles. You should understand that protons and neutrons are found in the nucleus, and that we can symbolize what's going on in the nucleus with an isotope symbol or also with an isotope name. We'll be going more deeply into electrons and atomic mass in the next podcast.